Cambridge University, 1908. A brilliant 30-year-old economist named Arthur Cecil Pigou has just been handed one of the most prestigious positions in economics, Alfred Marshall's chair. Marshall himself had chosen Pigou as his successor, seeing in this young scholar someone who could carry forward the grand tradition of economic thought. Pigou was more than just an academic. He was an avid free trader and a long-distance runner who had become a fixture at Cambridge until World War II. Walking through the industrial towns of early 20th century Britain, Pigou couldn't ignore what he saw: factory smoke blackening the sky, soot-covered buildings, and workers suffering from respiratory ailments. The Industrial Revolution had brought prosperity, but it had also brought pollution, and someone was paying a price that wasn't showing up in any ledger. This observation would lead Pigou to develop what he called a theory of externalities. In his 1920 book, The Economics of Welfare, building on Marshall's earlier concept, an externality, Pigou argued, is a cost imposed on others, or a benefit conferred on others, that isn't taken into account by the person taking the action. The factory owner doesn't pay for the damaged lungs or corroded buildings his smoke causes, so he produces too much pollution. Someone educating themselves creates benefits for others by becoming more useful and interesting and better for society. But it might underinvest in education because they don't capture all those benefits themselves. Pigou's solution was straightforward: tax the externalities, subsidize the positive externalities, make the person emitting the pollution pay. These would become known as Pigouvian taxes and subsidies, and they would dominate economic thinking about pollution for the next 40 years. Fast forward to 1931. A young socialist student named Ronald Coase boards a ship from Britain to America on a Coase traveling scholarship. He's visiting American factories to understand how modern capitalism really works. One day in New York, Coase drops in to meet Norman Thomas, the perennial Socialist Party presidential candidate. The conversation is what you'd expect: critiques of capitalism, discussions of central planning. But then, Coase visits Ford and General Motors, and something doesn't add up. If Lenin thought that the Soviet Union could run like one big factory, Coase wondered, then why do these massive American corporations seem to work so well? They're little planned economies operating within a broader market system. This puzzle would lead to Coase's first major contribution to economics, his 1937 paper, The Nature of the Firm. In it, he argued that firms exist because using markets involve costs, what he called marketing costs, but what economists now call transaction costs. If markets were costless to use, we'd all just contract with each other for everything. But because negotiating, writing contracts, and enforcing agreements all cost time and money, sometimes it's more efficient to bring activities into a single organization, a firm. That paper, written when Coase was just 27, would be cited thousands of times and help earn him the Nobel Prize in Economics in 1991. But it was his second paper, published 23 years later, that would directly challenge everything Pigou had studied. By 1960, these two economists, though they'd never really debate face-to-face, represented two opposing visions of how society could handle pollution and environmental harm. In Pigou's view, when a factory pollutes, it creates what he called an externality, a cost imposed on others that the factory owner doesn't have to pay for. His solution: the government intervenes, tax the pollution, subsidize the clean alternatives, make the polluter pay. In Coase's view, if the factories and the affected neighbors can talk to each other, why do they need the government at all? Let them negotiate, let them bargain. The market can solve it. The stakes of this debate couldn't be higher. It's not just academic theory, it's how we tackle climate change, air pollution, water contamination, and many other environmental challenges. The central question in environmental economics is, how much pollution should society accept? Your first instinct might be zero. However, what if eliminating that last 1% of pollution from a factory costs $100 million? What if eliminating the last 0.1% costs $1 billion? This is where economists introduce a crucial concept: opportunity cost. Every dollar spent on pollution control is a dollar that can't be spent on something else. That $100 million could instead be spent to build new hospitals. That $1 billion must come from the taxpayer, so every dollar spent on fighting pollution reduces what each member of society has in their own pockets. Literally, every dollar spent is an ice cream cone you cannot buy for your kid, a dollar you and your wife cannot save towards a down payment on a house, or a dollar you cannot give to a charity you personally care about. The question isn't simply what does cleanup cost, but rather what are we giving up to get this cleanup? This is society's dilemma, and economics offers a framework for thinking it through. The challenge is one reality every society faces. Resources are finite. Devoting resources to one problem means fewer resources are available to other problems. The opportunity cost of building an effluent treatment plant might be the medical care, education, or infrastructure improvements that same money could have provided. Economics helps us find the optimal balance, the point where we're getting the most value from our limited resources across all our competing needs. Imagine a factory with a smokestack pumping out pollution. The factory could install filters, small ones, medium ones, or even the massive industrial scrubbers that remove 90% of emissions. But each level of cleaning costs more than the last. Meanwhile, the pollution is causing real damage, corroding vehicles, deteriorating buildings, harming health. Pigou's brilliant insight was to think about this at the margin, that is, one unit at a time. This marginal thinking is fundamental to economics, but it's not how most people naturally think about problems. We tend to think in totals. How much does all the cleanup cost? Or how much harm does all the pollution cause? But Pigou realized that decisions aren't made that way. They're made incrementally, step by step. Think about it this way. When you're deciding whether to study for one more hour for your exam, you don't ask, what's the total value of all my studying? You ask, is the next hour worth it? When a business decides whether to hire another worker, they don't recalculate the value of their entire workforce. They ask, what will this additional person contribute? Pigou applied this same logic to pollution. The question isn't, should we control pollution or not? It's, should we control one more unit of pollution? And crucially, the answer changes depending on how much you've already controlled. The first ton of pollution you eliminate might be cheap to remove and might cause serious harm. The second ton might be slightly more expensive to remove, but still cause significant harm. It still might be worth it. But the 100th ton, maybe that requires installing expensive scrubbers, and at this point, you've already eliminated the worst pollution, so this last ton is causing minor damage. The marginal benefit doesn't justify the marginal cost. This is how we find what level of pollution to accept, anywhere from accepting all the pollution to eliminating all the pollution. Now we need to consider Pigou's framework. To do so, we need to introduce a couple of key concepts. First, marginal abatement cost. This is the cost of eliminating one more unit of pollution. Next, marginal environmental damage. This is the harm caused by one more unit of pollution. Pigou's rule results in the optimizing choice of reducing pollution until MAC equals MED, but no further. Consider the following diagram. This diagram captures Pigou's work visually. On the horizontal axis, we show the level of emissions from 0 on the left to completely unregulated E sub O on the right. As we move leftwards from E sub O, we're reducing emissions. We're doing more abatement. On the vertical axis, we measure cost per unit of pollution. These two curves tell the story. The MAC curve, marginal abatement cost, slopes upward as we move left. This shows that as we eliminate more and more pollution, each additional unit gets progressively more expensive to remove. The first bits of abatement are cheap, such as switching to a cleaner fuel in the case of the acid rain story from earlier. But as we push further, we need increasingly expensive technologies. The shape of this curve assumes firms are rational. They'll tackle the cheapest abatement options first and only resort to more expensive options when forced to go further. This assumption fits well with a free market. The other curve is the MED curve, the marginal environmental damage curve, and it slopes upward as we move right. This shows that each additional unit of pollution causes harm, and typically that harm increases as total pollution rises. The first bits of pollution in an otherwise pristine environment might cause relatively little harm, but as pollution accumulates, each additional unit may cause increasingly serious damage to human health and ecosystems. When these curves intersect, as marked in E star in the diagram, it is the efficient level of emissions. At this point, the cost of eliminating one more unit of pollution exactly equals the environmental damage that unit causes. To the left of E star, we've done too much abatement. The MAC curve sits above the MED curve, meaning we're spending more to eliminate pollution than that pollution was harming us. To the right of E star, we're doing too little. The MED curve sits above the MAC, meaning the pollution is causing more harm than it would cost to eliminate it. One useful feature of this diagram is that it is also possible to identify areas on the diagram which correspond to the total abatement costs incurred in cutting emissions from EO to E star, and the total benefit obtained in terms of reduced environmental damage. In each case, the area under the relevant marginal schedule represents the corresponding change in total costs for the overall change in emissions. The total abatement costs incurred in reducing emissions to E star from the unregulated level E sub 0 is the triangular area marked A on the diagram, and the total environmental benefit from this abatement is the sum of areas A and B, that is, the area under the MED schedule over the range from E sub O to E star. The total net benefit to society from this abatement is the difference between these two amounts, in other words, the area B. The diagram thus provides a clear visual illustration of the social gains from achieving the optimal level of abatement. You might object. Shouldn't polluters clean up all their pollution, not just the economically efficient amount? We might raise three responses. First, we're all polluters. You drive, you use electricity, you buy products made in factories. The cost of cleanup ultimately comes back to us as consumers through higher prices. This isn't about punishing polluters, it's about how much society wants to spend on environmental protection versus other goods and services. Second, efficiency doesn't mean fairness. The economically efficient solution might still be unfair. Maybe poor neighborhoods get polluted while rich neighborhoods stay clean. That's a problem, but it's a distribution problem, not an efficiency problem. We may need to solve both and solve them independently. Third, principles that ignore costs don't help make decisions. If we can't eliminate all pollution without shutting down all economic activity, we need some principle for deciding how much cleanup is worth it. It's 1959. Ronald Coase has just published The Problem of Social Cost in the Journal of Law and Economics. In it, he makes a claim that seems to contradict everything economists believe about pollution at the time. That under certain conditions, government intervention isn't necessary at all. Private bargaining between polluters and victims can solve the problem on its own. The free market economists at the University of Chicago should love this. It's arguing against government intervention after all. But they don't. They think Coase has made a fundamental error. This is too radical, even for them. So they invite him to dinner to straighten him out. The setting is the home of Aaron Director, an economist who had founded the Journal of Law and Economics. It's an academic, heavyweight bout. Around the table sit some of the most formidable minds in economics. Milton Friedman is there, the future Nobel laureate who would become the public face of free market economics. George Stigler is there too, another future Nobel winner. The room is filled with professors from Chicago's economics department, and they've all read Coase's paper. They all think he's wrong. The evening starts with dinner, then serious conversation begins. Coase presents his argument. The Chicago School economists push back. Friedman does most of the talking, as Stigler later recalled, as usual, but he's also doing most of the thinking, again, as usual. The debate is intense, 20 economists arrayed against one. Coase doesn't back down, he walks them through the logic step by step. The rancher and the farmer, the liability rules, the bargaining outcomes, the numbers on the chalkboard. Picture the scene. Voices rising, economists interrupting each other, someone jumping up to sketch a diagram, Friedman pacing as he formulates an objection, coffee being poured, cigarettes being smoked. It is the 1950s after all. The hours tick by. Slowly, the tide begins to turn. One economist sees it, then another. The logic is airtight. If transaction costs are indeed zero, Coase is right. The allocation of legal rights doesn't affect the final outcome, only who pays whom. Private bargaining really can reach the efficient solution without any government intervention. 2 hours after the debate began, George Stigler looks around the room and realizing something extraordinary has happened. It, he later wrote, had gone from 20 against 1 for Coase to 21 for Coase. Every single person in that room had changed their mind. Stigler's reflection captures his amazement. What an exhilarating event. I lamented afterward that we had not had the clairvoyance to tape it. These were some of the most accomplished economists of the 20th century. People who would win Nobel Prizes, economists who had spent decades thinking about markets and efficiency, and in the span of a single evening, one economist with a radical idea convinced all of them they'd been wrong about a fundamental question. It's one of the most remarkable moments in the history of economic thought, a paradigm shift happening in real time around a dinner table, fueled by nothing more than logic and argument. Stigler himself would later give Coase's insight a name, the Coase theorem, and that theorem would reshape how economists think about property rights, externalities, and the role of government in the economy. The ripples from that dinner party are still felt today. Coase presented a thought experiment. Imagine a cattle rancher whose cows occasionally wander onto a neighboring farmer's land and eat the crops. The Pigouvian solution is that you should tax the rancher or regulate how many cattle he can have. Coase questioned this, and here's his revolutionary insight. Consider one scenario. The rancher has no liability. The farmer could pay the rancher to reduce his herd. If the crop damage from an extra cow is $3 and the cow's profit to the rancher is $2, they could make a deal. The farmer pays the rancher something between $2 and $3 to get rid of that cow. Both sides win. Scenario 2, the rancher is legally liable for the damage. Now the rancher has to pay for any damage. For an extra cow causing $3 damage and earning $2 profit, the rancher won't add that cow. It's the same outcome, the same number of cows. Thus, Coase's stunning conclusion. If people can negotiate freely and transaction costs are zero, it doesn't matter who has the legal right. They'll bargain their way to the efficient outcome. The only thing, Coase's theorem undermined the automatic case for government regulation. If private bargaining can solve externality problems, why would we need Pigouvian taxes? Why do we need regulation at all? Just define property rights clearly and let people negotiate. The economists at the dinner party realized this changed everything. Of course, Coase built his theorem on a crucial assumption, that transaction costs were zero. This wasn't meant to describe reality perfectly, it was meant to isolate a key insight about property rights and efficiency. Coase's real question is, when are transaction costs low enough that Coasean bargaining can work, and when do they become prohibitive? Let's think carefully about the kind of transaction costs that might prevent efficient bargaining. 1. When coordination costs between many parties is involved. When pollution affects many people, those affected need some way to coordinate their response. If a power plant's emissions harm 100,000 residents in a medium-sized city, they face a classic collective action problem. This doesn't mean bargaining's impossible. We observe collective action succeeding in many contexts, class action lawsuits being a prime example. Legal and institutional structures can facilitate coordination. Homeowners associations, environmental groups, and community organizations all serve this coordinating function. The question isn't whether coordination can happen, but whether the costs of such coordination are low enough relative to the potential gains from bargaining. Second, free riding. This is where economics can be very subtle. When the benefits of abatement are non-excludable, that is, if the air gets cleaner, everyone in the area benefits, whether they contributed to paying for the cleanup or not, individuals have an incentive to free ride. Each person hopes others will pay while they enjoy the benefits for free. This doesn't result in nothing happening. Rather, we get what's called under-provision. Some bargaining may occur, but less than would be socially optimal. Perhaps the most affected individuals negotiate some reduction, but not the full amount that would be efficient if everyone would be compelled to contribute their fair share based on benefits received. 3. The role of markets in solving information problems. One might think that asymmetric information, for example, the rancher not knowing how much the farmer values their crops and vice versa, would doom bargaining. This objection misunderstands how markets work. Markets exist precisely to solve the information problem. Prices aggregate dispersed information and signal value. In repeated interactions, market participants learn about each other's valuations through their offers and counteroffers. The bargaining process reveals information. A farmer who truly values their crops highly will refuse low offers. A rancher with high abatement costs will refuse to accept low compensation. 4. Strategic bargaining behavior. A more serious concern arises when bargaining itself becomes costly due to strategic behavior. The specific issue here might be holdout problems and strategic delay. Imagine a factory negotiating with residents to compensate them for pollution. If any single resident can block the deal, they might hold out for a larger share, hoping to extract more of the surplus. Other parties might engage in strategic delay, deliberately dragging out negotiations to strengthen their bargaining position. This is costly in and of itself and may cause beneficial agreements to collapse. This is particularly problematic where property rights are ambiguous. If it's unclear who has the legal right, parties may invest in litigation rather than negotiation, hoping a court will assign them a stronger bargaining position. 5. Market power. When a large corporation negotiates with individual citizens, we might face a market power issue. The corporation may well be able to negotiate separately with each individual, playing them off against each other. An individual resident may lack the resources to hire lawyers or experts to assess their damages and negotiate effectively. This is both a fairness and efficiency issue. If corporations can use superior resources and bargaining position to pay less than the true damage caused, victims will accept too much pollution. The efficient outcome requires that corporations face the full social cost of its pollution, and market power and bargaining may prevent this. Of course, institutions help. Legal rights bring class actions. Rights to legal representation and requirements for environmental impact assessments can help level the playing field. These institutions often look rather like regulation, bringing us back around to the Pigouvian solutions. The Coase theorem isn't really about whether bargaining always works. Coase knew it often wouldn't. Rather, it's about understanding what happens when it does work and why it sometimes fails. When transaction costs are low, clearly defined property rights can enable efficient outcomes without regulatory intervention. When transaction costs are high, we may need to think carefully about whether regulatory solutions, like Pigouvian taxes, might achieve efficiency at lower social costs than attempting to facilitate bargaining. The theorem teaches us to think about designing institutions that lower transaction costs and not merely choosing between pure bargaining and pure regulation. Despite these limitations, Coase's insight remains crucial, especially in one area, that is, international environmental agreements. There's no world government that can force countries to reduce emissions. All international climate agreements are, by necessity, voluntary negotiations between sovereign nations, exactly the kind of bargaining that Coase described. By the 1980s, acid rain was devastating European forests. Dead trees stood like monuments to industrial pollution. Historic buildings were literally dissolving as sulfuric acid ate away at their stonework. The source? Mainly coal-fired power plants burning high sulfur coal, especially in Poland, Germany, and the UK. The sulfur dioxide they pumped out combined with water vapor in the atmosphere to create sulfuric acid, which fell as acid rain, often hundreds of kilometers away. This created a diplomatic nightmare. British power plants were killing Swedish forests. Now let's apply our economic analysis to this case. Step 1. Map the marginal abatement costs. Researchers at the International Institute for Applied Systems Analysis in Vienna calculated the MAC curves for each European country. They found the following. Switching to low sulfur coal was cheap. Building cleaner, new power plants was a moderate cost. Installing scrubbers on existing plants was expensive, costing tens of millions of dollars per plant. Crucially, the MAC varied wildly by country. Those burning high sulfur brown coal had lots of cheap abatement options. Those already using cleaner fuels faced high marginal costs. Step 2. Map where the damage fell. Using data from the European Monitoring and Evaluation Program, scientists tracked where each country's pollution ended up. Of the UK's 2.9 million tons of S2O emissions in 1991, only 1.1 million fell on the UK itself. The rest was spread across Europe. 131,000 tons in Scandinavia, 95,000 tons in Germany. Scandinavia's own emissions accounted for only 22% of its acid rain. The rest was imported. Step 3. Calculate national interests. A Swedish economist had an influential 1991 paper titled The Acid Rain Game, which laid out the logic. Countries like Norway and Sweden suffer enormously from acid rain, but cause relatively little. Countries like the UK cause significant damage abroad, but suffer relatively little at home. An efficient, Europe-wide agreement would require the UK to cut much more than countries like Norway, but such an agreement would make the UK worse off than doing nothing. This presented a negotiation dilemma. This is where Coase meets Pigou. The Pigouvian approach would be to calculate the efficient level of abatement for Europe as a whole, the MAC equal to the MED across all countries. The result would be major cuts needed, especially from exporting countries like the UK. The Coasean approach would be that countries would need to negotiate voluntarily. No country will sign an agreement which makes them worse off. The problem, of course, that the efficient solution makes some countries like the UK worse off. They'd have to spend more on abatement than they would gain in reduced acid rain imports. Option 1 of the solutions was that, in theory, benefiting countries like Sweden could pay the losing countries like the UK to participate. The overall gains were big enough to compensate the losers and still leave everyone better off. In practice, it was political poison. Imagine a Swedish politician explaining, "We're paying the people who destroyed our forests to stop destroying them." The second option was to weaken the agreement. Instead of the efficient outcome, everyone could settle for what would be accepted, even if it left significant benefits on the table. The UK didn't sign the first sulfur protocol in 1985. By the time they signed the second in 1994, the agreement had been adjusted, and the diplomatic costs of continual refusal had grown. Let's recap what we've learned. 1. The Pigou principle still holds. For most pollution problems, we need some form of collective action. Taxes, regulation, or cap-and-trade systems. Private bargaining doesn't always work when millions of people are affected. 2. Coase did change how we think. Before Coase, economists automatically assumed pollution required government control. After Coase, we now consider transaction costs. We ask questions like, could property rights and markets do some of the work? Could we design market-based solutions that harness Coasean bargaining? 3. International problems are the hardest. Like acid rain, we need coordinated action, but we can only achieve it through voluntary negotiation. 4. Efficiency isn't everything. Even when we can calculate the efficient level of pollution control, questions of fairness remain. Today's environment, economists are still, in essence, debating what Pigou and Coase started. The dinner party in Chicago never really ended. Pigou and Coase never met in person. Pigou died in 1959, just as Coase's famous paper was being written, but their debate continues in every environmental policy discussion today.